And you're on.
Good afternoon all, and welcome to the last in our series of spring lectures. My name is Charlotte Salter-Townsend. I work at the Botanic Gardens in Glasnevin as a guide and information officer, and it's my great joy to introduce today's speaker. So today we have Lee Davies from Kew Gardens. Lee is going to talk about, the topic is Your Cousin is a Mushroom, and they are more important than you think. So Lee has a background in paleontology and botany, and he became a curator of various collections before coming to the Fungarium in Kew Gardens. And he's been there for a few years now, about 6 years. And his main interest is communicating the collections, the fungi collections, to the public, and in looking at the cultural relationships between people and fungi. The first thing that comes to my mind there will be probably bread and booze, but you can also add all sorts of things that mix, and he'll talk about a few of those today. And I'm very excited because I first heard, the only time I heard Lee speak before made a big impression. It was about 2 years ago. I was lucky to attend a conference at Kew Gardens. It was run by the Botanic Gardens Education Network. And so it was all about educating people in Botanic Gardens. And we did a tour. It was an optional tour of the Fungarium. And we were there with Lee. I think it went a bit longer than expected, but we were all having such a good time. And we talked about it a lot afterwards, all of the delegates. So I was already interested in fungi, but he really set me on a path of wanting to find out a lot more and to incorporate it into my stories about the Botanic Gardens in Glasnevin. So I do think over recent times, I've noticed more and more people becoming interested in fungi, giving them more attention as they deserve, as a kingdom in their own right, alongside plants and animals and everything else. And I think, of course, the times that we're in, people are paying more attention to the natural world. So perhaps more of you have noticed fungi around you on your daily walks. Even in cities, you'll find a lot of lichen specimens and things like that. So there's always some to be found, not just the sort of more classic mushrooms. And I'm really looking forward to this. So I'm going to hand you over now to Lee, and he's going to talk for about 40 minutes or so. There'll be time for questions at the end. So do please type your questions into Ask a Question. And you can chat as you are now, introducing yourselves from around the world, which is fantastic. And my colleague Melissa is there, and she'll answer any technical kind of problems you might have. And, she'll be there to help you in the chat. And she's also mentioned to you that there's polls there at the bottom. You might have seen those. So we just put in a few kind of quiz questions just to sort of get you thinking about fungi, and we'll address those at the end of the talk as well. So without further ado, I'll hand over to Lee and his presentation, and again at the end we'll have a little discussion. Thank you.
Hi everyone. So yes, my name is Lee. I am one of the curators here at Kew Gardens Fungarium, which means I'm like a librarian of mushrooms. You can see part of the collection here behind me. We have like about 1.3 million specimens here in the collection. It's one of the biggest in the world, probably is the biggest. And it is also the best collection in the world. And I am biased, but the reason it's the best is we have probably the biggest representation of the world's fungal flora, if you like. We have about 60% of the world's known species here in the collection. We have about 30,000 what we call type specimens. So those are specimens that represent a species, if you like, the gold standard for that species to which all comparisons are made. And our collection goes back about 150 years. So we have a very large collection of historical material from all over the world, from if you like, the early days of mycological science in Britain and in Europe. So we're really important in that sense. And that's why we're the best collection. So my day-to-day job is like a librarian. I help people get access to the collections if they want to borrow material, if they want to do research like DNA sampling or microscopy work. Any new specimens coming into the collection I look after. I do the databasing, I incorporate them, and deal with all of that. I also do a lot of sort of science communication and talking about mushrooms like this. I think mushrooms are really cool. And I could probably talk about 2 hours on them if I wanted to, and go on for probably 3 until I pass out from lack of breath. There's so much about them that we can learn, and it's really interesting and cool like that. So what I'm going to talk about today is the relationships between people and fungi, and how humans have been using fungi for thousands of years. I'm going to kind of almost like a brief introduction to all of that and cover some of the really important areas. I could go on for hours talking about this. We talk about industrial stuff as well. So we're going to start with probably the most important question is, what makes a fungus a fungus? So fungi are their own kingdom. They are not plants and they're not animals. They are a discrete and unique group out there in the world. What makes them unique, if you like, is that like plants, they have a cell wall. And in the case of fungi, that cell wall is made of chitin. In plants, that cell wall is made of cellulose. You may have come across chitin before. It's the material that insects use to make their exoskeleton. It's the crunchy bit on spiders or beetles or flies. It's also the material that squid use to make their beaks. So squids and octopuses have a chitinous beak. Like animals, fungi are also heterotrophs. They have to get their food from the environment around them. They can't photosynthesize like plants can. So fungi have to get their food by digesting everything around them. And because of that, it has a big influence on how they live and how evolution has shaped them. And it's because of that that they have intersected with humans, and if you like, their adaptations have become useful, or we've discovered that they're useful to us, and so we've made use of them where we can. And they're also a hugely diverse group. We currently have about 144,000 species of fungi ascribed in the scientific literature, and there's probably something in the region of 2 to 3 million different species out there in the world. And the majority of those aren't big and showy and beautiful mushroom formers. They're probably small microfungi. So there's a picture of some of the sexiest looking fungi out there. You've got the typical mushroomy things. You've got coral fungi. You've got puffballs, earth stars, and then there's two from my favorite group. These are stinkhorn fungi, for obvious reasons. So the mushroom that we see, this thing that pops up above ground, is really only the tip of the iceberg, and is just the reproductive part of the actual fungus itself. So if you like, a mushroom is just the genitalia that spreads the spores and disperses the offspring to go and grow and form a new individual. The vast majority of a fungus, the bit that we can't see, the bit that's underground or living inside a rotting log or a tree or growing inside a plant, for instance, is the thing called the mycelium. So on the picture you can see it's this like thread-like mass. If you've ever had a compost heap and turned it over, you might see this sort of white filamentous film over things, or when bread goes moldy, it's that kind of thin filamentous soft material. And the mycelium is the bit that does all the work. It's the growing organism. It's the bit that feeds. It's the bit that fights against competition. Fungi are hugely competitive with each other. They go to war and they use chemical warfare to attack each other and kill the competition so they can grow and feed and eat everything that's around them. And it's this mycelium that has shaped the way that fungi interact with the environment. So the best way to describe this is a human being is a tube. We are a complex tube, admittedly. We take food, we stick it in one end, and then while it's inside us, it's safe and we can digest it. We can take all the nutrition we want, and then the bit that we don't need, we get rid of out the other end of the tube. A fungus is made up of threads, if you like. So there's no tube part. So to digest their food, they have to secrete digestive enzymes into the environment around them and break it down and then absorb those nutrients as they become available. And what this means is that they have competition for that food. If you're spending energy producing digestive enzymes to break down wood or leaves or any other organic matter, you don't want other fungi or bacteria or microorganisms in the soil to get to it before you do. So as well as secreting digestive enzymes, they also create other compounds to kill everything around them, whether it's fungus or a bacteria. And the digestive enzymes themselves can be really complex because fungi have evolved to break down stuff that nothing else could. So wood, for instance, the horns of things like cows and keratin, things that are really hard to break down, fungi have evolved to do. So they're really, really good biochemists, if you like, chemical engineers. So they are really good at just secreting lots of enzymes and compounds into the environment, and it's usually those compounds that humans make use of. So before I jump into all of that and how we've used them, I'm going to quickly address the fact that I've given this talk a really weird title, talking about your cousin is a mushroom, partly because it's catchy and gets people to come along, but partly also because it's true. So this is, if you like, a family tree of all living things on Earth, and most of it is made up of small things, bacteria and archaea, which are a bit like bacteria. They're tiny, tiny things. And you can see at the bottom, you are here, you are in Animalia, and next to that is fungi. So over the past couple of decades, there's been a lot of research looking at things like DNA and the molecular level of different organisms. And we used to think that fungi were kind of like plants, weird plants, but largely an aberrant type of plant. But now we know that actually fungi and humans are really closely related, and plants are actually quite far away. We're quite distant cousins to plants. So if you've eaten mushrooms today, or if you've had bread or beer, you are more closely related to the fungus that's done that than the vegetables you've eaten or the wheat that went into the bread. So we are really closely related to fungi, and we share a common ancestor. Plants, we split off from them over 1 billion years ago. So we are much closer cousins to fungi than plants. So just to address that, I'm now going to crack on to the fun stuff, if you like. So this mushroom you can see here, this is a thing called Amanita muscaria. This is the fly agaric, and this is the fungus that I think is probably more firmly embedded in human culture throughout, really across human culture in really intrinsic ways than any other mushroom. If you asked anyone to draw a fungus or a mushroom, this is the one that everyone would draw. And I'm starting with this one because this is one of my favorites. It's a really beautiful mushroom. And also I'm really interested in this because it's got a very unusual property in that it produces a compound, a chemical inside it called muscimol. And if humans eat this fungus, that muscimol does something quite interesting to us. So what happens is that, and people have known this for a long time, so if you eat an Amanita muscaria, you will hallucinate quite a lot. It's a very psychoactive fungus. And people have been eating this for several thousand years because it's hallucinogenic. I imagine there's religious reasons, cultural reasons, social reasons, and probably purely recreational reasons as well, because humans always like getting off their heads. We drink, we do drugs, illegal drugs, and this is an example of a drug that humans have been eating for several thousand years. We know from anthropological research over the past couple of centuries that this is the case, particularly in Eurasia. But there's also cave art in northern Africa. It's rock art. It's about 4,000 years old, I believe. And they're human figures, and their heads have been replaced with Amanita muscaria caps. And there's a group of about 10 of these mushroom-headed people. So if people are painting these onto rocks to last 4,000 years, it suggests that there is an important and integral relationship there between the mushroom and the people. A fun fact, maybe for the squeamish, is that only about 10% of the hallucinogen gets processed in your body and makes you hallucinate. The other 90% comes out in your urine. So you could, in theory, drink your urine the next day and hallucinate all over again. And allegedly, this is what people used to do. In Rome, they used to feed the mushrooms to their slaves and drink the slaves' urine to hallucinate rather than eat it themselves. There's a slightly poisonous compound in these things called pantherin. So by giving the slave the mushroom, they get the toxic part, so they might be sick and throw up and unwell, whereas you as the slave owner would get the pure hallucinogenic wee. And there's also another story, this may not be true, but it's a good one, is that people used to do this with reindeer up in the northernmost parts of Europe and into northern Asia. And they used to use the reindeer as a way of processing these Amanita muscaria before they had their ritual use of the hallucinogen itself. You give the reindeer the fungus, you eat the yellow snow, and then off you go. There's also a potential story that this is somehow related to Father Christmas and the stories around Father Christmas, because it's red and white. There's flying involved, there's reindeer, all of that sort of thing as well. Might be true, might not be, but it's a really good story nonetheless. this is a single fungus that people have had an intimate relationship with because it's hallucinogenic. There's a whole group of other fungi that we call magic mushrooms, which we've also been making use of for quite a long time. So this is about 170 different species belonging to the genus Psilocybe. So I think this is a picture of things called Psilocybe cubensis, which is a hallucinogenic fungus from Central America. We have 2 or 3 different species in Britain and in Europe that are also hallucinogenic. And this is another one that people have been using for thousands of years, particularly in Central America, but also in Europe. So on the right there, on the far right, you can see there's like a very faint drawing. And this is cave art from Algeria that's about 6,000 to 7,000 years old. And in the middle is a kind of a reconstruction to make it a bit clearer. And you can see this humanoid figure with what look like mushrooms growing out of its head, and out of its hands, and from all over its skin. There's also similar cave art in the same cave systems in the same area of people and fields of little psilocybe mushrooms, because they have quite a distinct little cap that's sort of quite pointed. And so this sort of demonstrates again that these are important enough to people to paint them on rocks, and they lasted several thousand years. And this is another fungus that has a hallucinogenic compound in it that people use recreationally, ritually, particularly we know in Central America they're used ritually as well. There's if like a kind of a mushroom cult. And what's probably most interesting, I mean, in Britain this is a Class A drug, by the way, so it's illegal to collect and do anything with these. I'll put that out there. There's a lot of research going on at the moment, and it appears in the press recently because they've been doing some clinical trials to see if this fungus, or if like the hallucinogenic compound, can be used to treat people with depression and other and sort of similar mental health problems. And it appears to be effectively a miracle drug. They've done some studies where I think the initial study was about 10 people who have severe depression that doesn't respond well to conventional antidepressant drugs. And they, in a controlled setting in a hospital with nurses, psychiatrists, all that, they gave all 10 of them a dose of psilocin, which is hallucinogen, and all 10 people tripped out. And afterwards, they kind of followed them up and they did a study. And they found that people had a significant improvement in their mental health, in some cases for several weeks from that single dose. And in a few of those 10 people, they found that they had a significant improvement for months afterwards. So this was something that was having a really dramatic and significant effect on their mental health. And there's been further studies, and it seems to continually show that this is dramatic improvement in people's mental health with none of the side effects of antidepressants, things like emotional blunting. And it's a much better general sense of well-being as a result of taking these. I think we're probably going to see this coming out in the next few years, is that these are being used to treat people with mental health and potentially other with people with depression and potentially other mental health conditions as well. It's really, really interesting. And there's a chap called Professor David Nutt, who is doing studies into this, and a lot of his work is really interesting. And I think you did a podcast with him. If you Google it, you might be able to find it. And he talks about the research and what's going on. But it's really, really interesting. And it's just, if you like, it's just a continuation of several thousand years of people using these for their psychoactive effects. That now it seems can be pharmaceutical on top of ritual and cultural and social. But it's really, really good. Our historical relationship with fungi doesn't really end there. We've used fungi as an object in and of itself, or as a material. This looks like some sort of monstrous face from a nightmare you had after eating too much cheese. But this is a ritual mask from Nepal. This is about 250 years old, and this is a Ganoderma fungus. So this is a thing called Ganoderma lucidum, I believe. I think they call it reishi in the Far East, and it's been carved into a mask. And culturally in Nepal, where these masks are made, they believe that they keep away evil spirits. And this isn't a small fungus as well. This is probably bigger than a human head. I have a similar specimen of the same species here, and it's a whopper. This is one of the biggest specimens we've got. So I hold it next to my face. This gives you an indication that these things can get quite big. This is Ganoderma lucidum. Unfortunately, I'm not allowed to carve this one up and make a mask out of it because it's part of our collection and I get in trouble. But maybe that's a craft project for this autumn, perhaps. And this is not the only example of these being used. You may have heard of this, the Iceman Otzi, who was found in, I think it's the Italian or Swiss Alps. On his body, they found 2 chunks of fungus, and they were carved into balls. One of them was a thing called Fomes fomentarius, it's a hoof fungus, and the other was a birch polypore. You might see this on birch trees in the autumn. Beautiful, beautiful bracket fungus. And it looks like, I mean, they do have some medicinal use. Birch polypore does contain an antimicrobial. But in this case, these were 2 like carved balls of the fungus that were threaded onto leather thong. And it's thought that he was using them as kind of a toggle on his various pouches. So using these fungi as more of a decorative item rather than a medicinal item. And it's not the only time that we use fungi as a kind of a decorative, if you like. So this is a bag here on the right. This is a bag out of Kew's economic botany collection. This is not a small bag. It's, you know, kind of a big handbag size, and it's made with fungus. It's a material called amadou. So the one on the left there is a thing called Fomes fomentarius. It's this hoof fungus, and they have a layer underneath that hard exterior that feels like suede. It's actually a really soft suede material. And if you strip out the hard part and the underneath part, you end up with this sheet of a suedey material that gets made into things like bags, hats, purses, things like that. And this, particularly in Eastern Europe, this is the case. So sort of Romania, Bulgaria, and into Hungary. And there's like a whole industry around collecting these fungi and turning them into these objects. The hats are really nice. But the bag there, that handbag, that's what is like probably the most decorative thing I've come across. And these, you're not going to get like outfits made of these because the hoof fungus, it probably doesn't grow more than about 2 feet across. And we've got one in the collection behind, which would have been about a semicircular shape, about 2 foot across. And you could have maybe made a bag or a hat with it. But the material is so soft, honest to God. If you could make like a sweater out of this amadou stuff, you'd never take it off. It's wonderful. I've got a piece of it at the back. Feels fantastic. There's also a different type of fungus. It's a little mushroom called a marasmius. It grows in tropical America, the tropical Amazon. And the mycelium from this marasmius grows really hard and tough, and it forms these thick, black, almost like bootlaces, if you like. And they get collected. They get collected by the local cultural tribe, and they make them into baskets. We have a basket in the collection here at Kew, which has these, it's mostly made of plant material, but it has these black bootlace fibers woven into it for decorative purposes. And the cultural group who make this, they have a whole ritualized collecting process for these fungi. They have songs that they sing to the fungus as they're collecting them and they're doing the weaving. It's a new species of fungus known to science. I think it was published, I want to say last year, but that was COVID year. So I think it was 2019. This was recently just published. It was certainly described for the first time in the scientific literature, but it's been known about for centuries, if not millennia, by people, indigenous people in the Amazon. And there are similar fungi that grow in the Far East or Southeast Asia that produce these bootlace-like mycelia. And they get collected and woven as well. There's even birds that collect these bootlace type mycelia to weave into their nests. They're really, really interesting. If I could get one of those bird nests here, I'd be a very happy man. Culturally, fungi have got everywhere else, and particularly into popular culture as well. I'm ashamed to say I had to look up Pokemon on the internet, and I found that there are about 7 or 8 Pokemon that are mushroom based. As an example of popular culture, modern popular culture where fungi have got in. There's also a lot of historical folkloric connection with fungi as well. So there's a couple of Christmas cards there on the left. And if you Google sort of fungus Christmas card, there are whole slews of European Christmas cards that seem to have mushrooms in them. And almost exclusively, it's these Amanita muscaria again. So that there's a little, what looks like a family of Amanita muscaria coming into a house, and that child doesn't seem at all phased that there are walking mushrooms with faces, but he's delighted to see them. Who knows? Or children collecting Amanita muscaria for whatever reason at Christmas time. Who knows? And you find them in things like computer games, things like Mario, for instance. It's this Amanita muscaria, this typical toadstool, if you like, has found its way all throughout these sorts of cultural representations, right through from postcards and Christmas cards, video games, through into things like Disney as well. If you look at the mushrooms in Fantasia, those are Amanitas again. And this is this image that's pervaded right through culture, to the point where if you ask a child to draw a mushroom, it's this exact one again. And then there's, of course, all the, if you like, the folkloric instances where fungi have really got into the human psyche. So fairy rings, for instance, there's these circles, almost perfect circles of mushrooms that we find growing. There's a whole lot of folklore about don't step inside it, you'll disappear, you'll get kidnapped by the fairies, because they're so odd and very ephemeral as well. So these mushrooms only appear for a few days a year, and for them to appear suddenly out of nowhere in a perfect circle is really, really strange to human beings, if you like. It's a very odd occurrence. And because of that, they have a whole lot of associations to do with things like fairies, witchcraft, magic, and odd stuff. To the extent where it's influenced the way that we look at fungi. In Europe, particularly, well, in parts of Europe, particularly the north and the northwest of Europe, including Britain, for instance, we're very mycophobic. We don't like fungi. The name toadstool, associates them with toads. We tend to think of them as warty, horrible little things. They're adorable, they're lovely. And so they've kind of entered the cultural psyche as something to be worried about or scared of. And a lot of names for them tend to have associations that are not so nice. They have things like witch's butter or dog's vomit. Things that are, if you like, create a feeling of this isn't safe. And so we don't generally, as a culture, collect fungi. We don't go out and harvest them to eat. Whereas if you go to places in southern and central Europe, they're mycophilic. So they have a whole culture embedded within them of going out and harvesting edible mushrooms and eating them. They have a very, very different relationship with mushrooms that you find out in the wild, if you like. And that's a very a sharp cultural contrast in how we look at these things. And there's probably a good reason for it, but off the top of my head, I can't imagine what it is, because a lot of the fungi that are collected in sort of, if you go into like Poland and Germany, for instance, are the same fungi that we get growing in Britain. And the ones that maybe you should be scared of in Britain, some of the poisonous ones, or even the hallucinogenic ones, are also fungi you find elsewhere in Europe. It's a strange way that culturally we've just diverged and evolved into this mycophobic or mycophilic mindset. I should have put it, there's one more picture on here, which on the right. So this is a 13th century fresco from Italy. And this is Adam and Eve in the Garden of Eden. And that in the middle is meant to be the tree of knowledge. And it's a mushroom. And it probably is an Amanita muscaria again. So you may have come across it. There's a kind of an idea that Christianity started off as a mushroom cult. There's a book published called The Holy Cross and the Sacred Mushroom, I think it's called. And it puts forward this idea that Christianity started as a hallucinogenic mushroom cult, which is a really bonkers, but also a really interesting idea. And I think this fresco here of the Tree of Knowledge probably kind of continues that idea and shows that it's not necessarily an old idea, because you've clearly got Adam and Eve eating what appears to be a psychoactive fungus, or at least hanging out next to a giant psychoactive fungus. Religiously, there's also, if you look a bit further east and you head towards sort of India and the furthest parts of Asia, you find that there's in mythology there's this substance called soma. And soma is this drink that gives the gods immortality and all their special powers. And no one's really been sure what soma is. In a lot of the hymns and the songs in the Vedas, the Vedic religion and culture, they talk about the preparation of soma and making soma, but they never say what it is. So those people thought it was cannabis or some other psychoactive plant, but it's now thought actually it was a mushroom, and it was one of these Amanita muscarias. There's a lot of, if you like, circumstantial evidence of this, but there was a carpet or a rug tapestry found, I think it was only a few years ago, which is several hundred years old, which depicts two people making soma. This is a piece of material found in a burial, I should say. Two people making soma, and one of them is holding an Amanita muscaria. It shows that probably soma was considered this hugely psychoactive drink that gave the gods all their power. So this idea probably spread further west, and maybe there is some influence there between ideas of early Christianity and hallucinogens and all that sort of thing. We've kind of gone back into drugs and hallucinating again. I should probably move on because I could go on about that for quite a long. So we've done drugs, materials, pop culture. The other one that is a hugely important thing is food. We eat a lot of fungi. We eat a lot of mushrooms. And it's not just the mushrooms that we eat. I could put 20 quid that everybody listening to this has eaten a fungus or a fungal product today. Charlotte said at the beginning, bread, beer. I mean, if you've had beer already, good on you, because it's only just gone lunchtime. Bread and beer use yeast, which is a single cell fungus, to be made. Brewing was discovered a few thousand years ago. Bread making similarly. And then there's also all the other things that we use fungi for to make products for our food. If you've eaten any kind of jelly sweets today, things like Haribos or Percy Pigs, for instance, or in fact, most things like soft drinks or anything sweet products, really. If you were to look at the back, you'll see in the ingredients, it'll have citric acid. Now, citric acid used to be only obtainable from lemons. And so they used to grow huge lemon groves to produce citric acid. Roll forward until a few decades ago, and they learned how to make citric acid using yeast by taking the gene for citric acid, sticking it in a yeast, and then fermenting it in industrial quantities to make vast amounts of citric acid quicker, easier, and cheaper. So if you've eaten anything with citric acid in it today, you'll have eaten something made by a fungus. Or if you've eaten things like soy sauce, tempeh, any of the chocolate, in fact, uses a kind of a rudimentary fermentation as part of making it. So that, fungi are, whilst not the mushrooms that we eat, they've become an integral part of our food industry and play a part in the manufacture of just about everything we eat. I hate mushrooms. They're disgusting. I will never eat them. They're like having slugs in your mouth. But I'm fully on board with the idea of all the things that you can make with yeast, like bread and beer, or of course one of the major food groups, which is cheese. All our best cheeses require fungus. There's a genus of fungus called Penicillium, which also gives us antibiotics, but more importantly, it gives us things like camembert and brie. That white, fluffy, soft part of any camembert is the fungus itself, and it has turned boring old cow's milk into something fantastic to eat. Let me think, what else we talk about? We in the West are fairly boring when it comes to what fungi we eat. We eat about 85% of all the mushrooms that we eat are only one of about 5 species of fungus. You might think if you go to a supermarket, you'll see a whole range of mushrooms available. You'll have button mushrooms, closed cap mushrooms, chestnut mushrooms, porcini, also portobello mushrooms. All of those I've just listed there are a single species of mushroom. It's a thing called Agaricus bisperus, and they are all just different forms of the same species. And that is about 90% of what you'll see in a supermarket. You may see some shiitakes and oyster mushrooms as well, but those handful of species that we eat are it's about 90%, 85-90% of what we consume. We're really boring in that respect. If you go to the Far East, particularly China and Southeast Asia, they cultivate and eat hundreds of different species. There's a much richer culture of eating the different fungi that are available for people, and most of those you can grow as well. Or a lot of those you can grow. There's about 100 species that you can farm. And there's a lot of potential there for new types of agriculture around mushrooms. Mushrooms are really good. They're one of the only non-animal sources of vitamin D, for instance. They're also really good for certain minerals, and also they're really rich in protein as well. So we really should look at cultivating a bigger range of fungi and mushrooms to incorporate. You chop them up small, I'll eat them, but there's a lot of potential there. The picture on there is a fungus. It's a group called termitomyces. It only grows in association with termite mounds. And in Asia and into Africa, this is a really sought after food source. This is like, if you like, a really desirable fungus to collect and eat. And at the moment, it's only available through wild harvesting. But because it's what we call a saprophytic fungus, it just breaks down organic matter. There is potential that we could bring this into cultivation and farm it. And it would be, you could grow it on agricultural waste. You could grow it on stuff that you can't eat. So there's a potential for really sustainable, highly nutritious food sources if we can bring this into cultivation. And the same goes for all sorts of other fungi that we really like as well. They're a really sustainable and healthy food source. I could go on about that again for another half an hour, but I have to keep moving on. And I'm going to move back onto drugs, but of a different kind quickly. So there's everyone's heard of penicillin. This is a wonder drug that was discovered about 100 years ago now, and then entered into use in the 40s and 50s, and antibiotics have revolutionized the world. But they're not the most exciting kind of fungus that we get bugs from. On the right there, what you can see, the little blobs, those are the larvae of cicadas, and they've been parasitized, consumed from within, and killed by a fungus. And this fungus is really important because it produces a chemical that is now used as the most widely available and common drug for treating multiple sclerosis. And this group of fungi, we tend to call them loosely zombie fungi because they do awful, horrible things to insects. They infect them, they grow inside them, and then when they've finished eating the insides, they burst out of the insect's head and spread their spores. And in the case of ants, they basically turn the ant into a puppet, and they control its behavior, and they control its jaw muscles, and make it do things before killing it and bursting out of its head. And this group of zombie fungi, as we call them, they produce a whole range of compounds that we use now for really major and important pharmaceutical drugs. So there's this compound fingolimod that's used for multiple sclerosis. If anybody who's watching or knows somebody who's had an organ transplant, for instance, the main group of drugs used to treat people with organ transplant as an immunosuppressant to stop their body rejecting the drug. That drug is a thing called cyclosporin, and it comes from one of these zombie fungus as well. There's also another drug called cordycepin, which is being investigated because it does something really interesting to cancer cells, which looks like it may be able to help in the treatment of cancers. There's a whole range of information out there on zombie and these drugs as well, so please do look that up. I need to move on to the last couple of things because I realized I'm already about to start going over my 40 minutes. I got carried away at the hallucination. So the amadou that I showed you earlier is an example of a historical use of fungi to make materials, and also that ritual mask as well. At the moment, there are companies that have started manufacturing a kind of mushroom leather. So this is taking that idea of amadou and bringing it into an industrial setting and making what is, for all intents and purposes, leather without the need for cattle. And there's two companies doing it, one called Ecovative and one called Mycoworks. And they've taken a Ganoderma, it's a type of Ganoderma like that whopping one I held up earlier. And you can farm it and grow it on agricultural waste, things like corn husks, straw, paper, all of that. And if you treat it in a certain way, you can turn it into sheets of leather. So you could make sofas, you could make clothes, and you can do this effectively in a warehouse. So you can grow really intensively, low ecological impact to produce things that are, compared to cattle leather, a massive reduction in the amount of resources that are needed in terms of water, food, and land. And it's really, really interesting stuff. And you can texture it as well. You can texture it and color it to make it look like anything you want. You could make it look like ostrich leather, crocodile leather, anything like that. It's really, really interesting. And even beyond that, because we know how some fungi work and the sorts of conditions they like, we can actually grow a fungal-based alternative to styrofoam. So oyster mushrooms are really good at this. So the oyster mushrooms you can buy in a supermarket, if you put them in a mold, like say a bowl or a wall panel, a square mold, which is filled with damp straw, and let it go, it will grow, it will fill that space. And then if you bake it, you will kill it and dry it out. And you can make what is a much better alternative to styrofoam, not only in terms of material properties, but also that it's entirely compostable. So if you were to buy a piece of, a new washing machine, they deliver it to your house, you could have this mycofoam packaging. You could recycle the cardboard, you could put the mycofoam on your garden, and it will all break down and it will be completely compostable, compared to really horrible styrofoam stuff that's a swine to get rid of in the bins and can't be recycled. And you could go from making decorative items like bowls to wall panels. There's even talk of using these sorts of fungi that break down organic matter like this to build future buildings on Mars when humans eventually go to Mars, because you can use the waste that people produce. And this all comes from the fungus's ability to break down organic matter and turn it into food as it's growing and as the mycelium is doing its thing. It's this, if you like, the chemical engineer part of fungi that have enabled us potentially to build colonies on Mars or to replace some of the most damaging materials that we currently use. And there's a lot of scope to use fungi for other things, everything from cleaning up contaminated land, eating plastics. There's a fungus that seems to eat plastic out there, we've discovered a couple of years ago. And I think there's a potential that fungi could really have a big impact on some of the most challenging things that are going on in the world in the future. And we really have basically scratched the surface. Okay, I should stop there because I've just hit 40 minutes. So I think I will quickly take a quick drink. And if you have any questions, I think we should crack on with that.
Hello again. Back questions. Sorry. That was fantastically. That really covered a lot in a short time, and I'm sure a lot of people felt they could have listened to you a lot longer as well. But what I'm hoping now is that we'll be able to interact with some of their questions, and I do hope that people as well get a chance to follow some other resources and learn more. And one of the nicest things happening over there in the comments, people are sharing podcasts and talks and books that they've enjoyed about fungi. So I think a lot of us are going to continue on. I might just indulge myself in a question or two before I open the box of questions, if that's all right.
Go for it.
So just thinking about how, you said about 144,000 species are described scientifically, but there are 2 to 3 million out there. And I'm sure there's a proportion of those that humans are interacting with, and we may not know about them scientifically. And I know that in some cases, people have, mushrooms or fungi have been found where people didn't expect to find them. So not necessarily a mycologist finding them in the field. I think I read something, or maybe you even mentioned it to me, about an investigation of someone had like a packet of food and there was something in it that was not described.
Oh yes, yeah. This is actually a guy who used to work here in the Fungarium.
Right, yeah.
A researcher here. His wife bought some dried porcini mushrooms. So there's something called Boleta sedulis. And you can't farm this fungus. It has to be in a symbiotic relationship with a tree. So these can only be wild collected. And I think these came from China. So his wife had bought these porcini mushrooms and had a dried packet. And he thought for fun, he'd bring them into work and sequence them. So he took 13 pieces and did DNA sequencing on all 13 and discovered that none of them were Boleta sedulis. there were 3 different species actually in there, and all of them were new to science.
That's even more amazing than I remembered. Yeah, one example, and who knows what else you might have in your kitchen. And to us, they taste the same if you like mushrooms, but they are different species, so they're just so mysterious. That way.
Yeah,
It's amazing.
I think just because there's a lot out there that we still don't know. And I think we assume that individual species look different enough that we can tell it apart, and it just goes to show that lots of things that look very similar on the macro scale and also on the micro scale are actually distinct species in and of themselves. It's really easy to accidentally find a new species of fungus, even here in the collections. There was, I think it was in 2018, when we did this State of the World's Fungi report, they were talking about new discoveries over the past year. And I think they discovered a new type of fungus on a child's school bag, under someone's fingernail, and on a piece on a painting.
Wow.
Just like everywhere in quite gross places as well.
Yeah. I was going to say it's great incentive to pursue a career or research in mushrooms or in fungi.
Yeah.
But yeah.
I think beetles or fungi are the way to go if you want to find new species.
If you want to make
plants, everyone's done plants. There's we'll find a few new ones, but they're mostly done. Don't tell my colleagues that. But there's millions of fungi left to go. Yeah. And there's whole places in the world where as scientists we haven't been and looked at what's available and what people are using.
Yeah.
So there people maybe have a culture out collecting and eating stuff, but from in the scientific sense that we still haven't found yet.
Yeah, and you have to bring them to the lab to identify them in many cases. It's not so simple.
Yeah. I mean, exactly. DNA sequencing is fairly cheap and easy these days. So as a standard practice, anything we collect in the field, we will hopefully do DNA barcoding on. So the most recent field trips that we went on, we did 2 trips to Colombia, and everything that we collected has been sampled ready for barcoding. So I think all of this stuff to do, the porcini mushrooms and accidentally finding new things in the collections, it kind of shows that we have to do DNA sequencing with fungi these days.
Brilliant. And one more question from me, just thinking from the plant perspective, because I'm representing the Botanic Gardens, and we do have our small collection of fungi in our herbarium as well.
Yep.
Lichens, which are a whole other subject, really, in some ways. Obviously, they relate. But yeah, just thinking about the relationship between plants and fungi, that could be a whole other talk. But very briefly, I know that it's emerging that the connection between plants and fungi is much closer than we thought, going back a lot further, going back to the arrival of plants on land, it's been said. That raised some of the questions actually in the box that we'll get on to later. But yeah, is it true that there's fungi that actually live inside plants?
Yes. So there's a whole group of fungi. They're not a discrete taxonomic group. It's like an ecological niche that lots of different fungi have gone to. So we call them endophytes. So these are fungi that live inside plants without causing any disease. So they're non-symptomatic, they're non-pathogenic almost.
That's important.
And and you find it from the roots right up to the seeds, and they're kind of complete, entirely pervasive through the plant, and they don't harm it at all. But what they seem to do is they help the plant out in some ways, in really odd ways. It's like they give some plants superpowers. The best example, there's a grass that grows near hot springs in Yellowstone. And the soil is 30, 40 degrees centigrade because of these hot springs.
Yeah.
But the grass can grow there because there's a fungus inside it, which kind of supercharges it. If you got rid of the fungus, the plant dies and withers, it can't cope. But because this fungus is in there, helping it out and supporting it, it can survive. And that's something people can use. There's even been potential use of introducing that species of fungus into agricultural crops, particularly in countries where they're prone to high temperatures and drought. There's I think mung beans in India, they've done it, and they find that by introducing this, you get 30% bigger yields of bean because the fungus has helped out the plant. And it's everything from allowing plants to tolerate high salinity to drought, and potentially a little bit of pest control as well. there's potential that they produce compounds that insects don't like, but it helps the plant from being eaten.
Yeah, wow. So this, again, looking to the future, there's so much to explore. So I better get around to the audience question. There's some good ones in here. There's 17.
Good.
The questions in order of popularity. So, do we need to be careful with invasive fungi as we do with invasive plants and animals?
Good question.
Yeah.
Probably yes, but also at the moment, it's probably the only way I can say is we don't know. If a fungus isn't pathogenic, so if it's not a disease-causing fungus, then we really don't know. There are fungi, so there have been some studies done on this. The one that springs to mind was in Colombia. They have pine plantations in Colombia. They get the trees from, I think it's South Africa, and those trees have been inoculated with a symbiotic fungus, one of these what we call mycorrhizal fungi, because trees need to have a mycorrhizal fungus, and it gives them a head start. So the fungus that's inoculated with has been cultured from species collected in Europe. So what's happened is you have these trees brought to Colombia in plantations with European fungi on them, which are non-native, and so you find that European fungi are now naturalizing and spreading in Colombia. What isn't known is whether they outcompete some of the native Colombian fungi that would normally associate with all of their trees. So there's been the beginnings. This actually, again, it comes back to Amanita muscaria. This is one of the common ones. The photo I took, that's from Colombia when we were there a few years ago. And you find it now as if like it's escaped the plantations, and you find it symbiotically growing with the endemic oak trees in Colombia.
Wow, new associations.
So I think it's more a case that we don't know.
Yeah.
And it's probably better to err on the side of caution and avoid it if we can.
Yeah.
But one thing it's worth bearing in mind is that fungi produce tiny spores that drift on the wind, and they stick to shoes and clothes. It's really difficult to keep them within national borders. And they don't care about borders, for instance, either. So we probably should be careful until we understand more. But like anything else to do with fungi, we don't know enough because they're not sexy and cute like animals. They're not pretty or anything like plants. And also because most of the time you can't see them because they're hidden underground. That's kind of that's, if you like, works against them. But there is potential. They might be a problem, but again, we don't know. And I think it's probably easier to err on the side of caution and avoid this if we can. Because if, for instance, there's sticking with the mycorrhizal fungi and inoculating trees, you could use mycorrhizal fungi from that area or that country rather than buying in an industrially produced culture from Europe and using it all over the world. It's who knows?
Yeah, definitely. There's a lot to think about there. The next question is, can you suggest any fungi books, please? And I have seen some great suggestions amongst our audience there in the chat, but any particulars from you?
There are there's one book. It's I've not read it, but I've heard good things. My neighbor has it and he's going to lend it to you when she finishes it. It's a thing called it's a book by a guy called Merlin Sheldrake. Very memorable name. It's called Entangled Life, which apparently is brilliant. Megan, if you're watching, I hope you are. Can you lend it to me, please? So that's meant to be a really good book. I'd be stupid if I didn't recommend the book that Kew has published. It's a book called Fungarium. It's a big coffee table type book. Big, bright, really, really beautiful drawings of fungi, and then fairly layman term information about everything from biology through to all the different groups of fungi, kind of laying out as a kind of good introduction across the whole of mycological science. And it's only like 20 quid. It's a good intro book that looks nice.
Those are great recommendations. They're very accessible, yet most people will learn something really.
Yeah, accessible. I think those are the two accessible ones I can think of. There's others by authors. I think Paul Stamets. He's a huge fungal advocate. So some of those, if they're available, maybe have a look at.
A lot of stuff online, like articles and podcasts and all that with him.
Yeah, there's a lot of good podcasts out there, articles. I'm trying to think if I can think. I think probably the best art. I think if you look in the news thing, there's a lot of stuff in the news over the past few years about to do things with the hallucinogenic fungi for depression, and the way that people are using fungi to produce materials like things like the myco leather, the foam, all of that. All this kind of new fungal sciencey stuff. But no one has yet done a really good TV program all about mushrooms that I think I can think of.
Yeah, I can't wait to see it.
Hope
you're on it.
Oh.
So, why aren't all these amazing fungi-based alternatives, etc., in wider use right now, and how can we help make the change?
I think it's largely because they're relatively recent discoveries, and also there's the economics of it.
Yeah.
Making a big switch from one thing to another takes a lot of consumer willpower and an economic investment. So it's happening slowly. I guess it's like electric cars, they're getting there, but the weight of economics is against them at the moment.
Mm-hmm.
Same with things like solar panels on roofs. It was a slow start, but once the economics gets right, it snowballs and becomes more popular and it becomes more affordable. From what I know, so the car industry uses a lot of leather. And from what I understand, from conversations I had with one of the guys who makes this fungal leather, they are looking to move into using fungal leathers sooner rather than later because the price of cow-based leather is going up.
Yeah.
I think once you hit that economic tipping point, it will happen. Other things like the leather. I think one of the companies is going with luxury products, which is a shame because not all of us can afford a Hermes handbag.
Yeah.
I don't think it would suit a Hermes handbag on me. So I think it'll happen just slowly. And when those things become available, people need to choose to use them.
Yeah. I saw that IKEA are talking about, as a big company now, they're talking about using what's the term again? The packaging.
The mycofoam. I saw something they're going fully circular by 2030, which I'm assuming means that they will do it. And by the time they buy into doing that, the company, I think it's Ecovative, will be in a position to scale up industrially, and so they will be able to meet their orders and other people. So I think it's coming, and over the next 7 years, by the next end of 2030, I think it'll be available. Smaller consumer products, I think, are harder to come up with. You might find that mushroom foam insulation becomes a thing. So if you build a house, choose the mushroom foam insulation.
Yeah. Next question. I'm wondering about the potential importance of mycorrhizal fungi, so those are the ones that make associations with roots of plants, for carbon capture, and wondering, can tree roots be seeded with specific species to that end? So that relates back to Colombia.
Yeah, they can be seeded. If people plant trees, you can buy, I think they call it mycorrhiza spawn, and you sprinkle that over the roots and you plant it, and that inoculates that tree. But again, you need to be careful because you don't know. Quite often, you don't know what species are in there, and you could, in theory, just plant a tree, and there will be fungi in the soil that will colonize it, particularly if there are other trees nearby. If you were going to a virgin site, almost like just grassland that you were replanting with trees, you would want to inoculate it to give them a head start, because there will be no mycorrhizal fungus necessarily in that soil. So by inoculating it with, you could use things that are edible as well. So you could go with truffles. There's people now farm truffles using forests. You could use things like porcinis, or there's a group of things called brittle gills, russula. There are lots of edible fungi that are mycorrhizal. So you could inoculate the ones you want to eat, and so you get double bubble. You get your tree takes off well, plus you also get an annual harvest of mushrooms. It's definitely doable with consideration of what you're inoculating with and where you're doing it as well. and some fungi only really like to form a mycorrhizal association with particular species of tree, or they'll certainly have a favorite.
Yeah, great stuff. Okay, I think I know the answer to this. Do we know which reach land first, fungi or plants? Although maybe that's not, we don't know for certain.
We don't know for sure. I'm sure I read something about this the other day. There was, we know that the moment, I think as you mentioned about mycorrhizal fungi, the moment we find the earliest ecosystems we have on land where there's fossil evidence, there's one in Scotland which is like brilliant. You find that there are mycorrhizal fungi associating with those really, really simple early land plants. I'm sure I saw something that there were fungi on land, what look like early fungal or fossil fungal tissues on land, or at least in terrestrial sediments, earlier than plants. It's probably a case of same time.
Yeah.
And someone could find something tomorrow that will change it completely.
Yeah.
But it's probably similar sorts of times.
Yeah.
Because they can often rely on one another as well.
It sounds like they've been together from the start almost.
Yeah. Because the fungus needs organic material to eat, and the plant is what provides that by when it dies. So you've got to have a fungus to get onto land. There has to be something to eat, and so it's a very simultaneous process, I guess.
Great. How about fungus for neutralizing radiation in the soil? So I think there's
yes,
noble there, isn't there?
There is. So there's a whole, again, I could talk an hour on this. Yeah. Well, half an hour, so there's a thing called bioremediation. So this is the process of using biological processes to clean contaminated soils. So there are fungi, particularly oyster mushrooms. These oyster mushrooms are amazing. They will absorb and concentrate into their tissues things like radioactive isotopes, heavy metals, so things like lead, some of these heavy toxic metals, particularly on things like mining sites. So that what you could do in theory is, if you then harvest the mushrooms and take them away, you're slowly depleting those isotopes in the soil. They don't neutralize them as such, because all it does is absorb them into itself and concentrates it. So it doesn't destroy the isotope. So you could harvest the mushrooms, take them somewhere safe and dispose of them safely. And over time, it will deplete the amount in the soil. What fungi can do is they can eat and break down other chemicals. So things like crude oil. So if there's crude oil spilled on land, industrial land, or industrial chemicals that have been dumped, they can break down some of those and actively, in that case, break them down and destroy them and clean that soil up.
Wow. Yeah.
And clean. They can use like straw bales inoculated with oyster mushroom, put them into river courses that are polluted, and the fungus will again absorb and break down pollutants in that. There's a whole
amazing.
They're really just too amazing for words.
Are easy enough to cultivate, which is fantastic.
Yeah. I mean, oyster mushrooms are super simple. Like, you can do it at home with a bag of straw, and you can make mycofoam, bioremediation, and food all in one. Well, you wouldn't want to do it all in one, because the bioremediating one would have radioactive stuff in it. But potentially, it's a wonderful species.
Yeah. So here's a philosophical question: is there any evidence for sentience or sociality in mushrooms?
Sentience, not as we understand sentience at the moment. Sociality, sort of, in a more passive way than active. So this is going back to mycorrhizal fungi. This could take a while to explain, so I probably won't go into depth. So mycorrhizal fungi, they grow into and form a close link with the roots of trees and plants. The fungus feeds the plant nutrients from the soil and water. In exchange, the plant feeds the fungus sugars and fats that it produces through photosynthesis. And there's a constant exchange. Any one tree could be connected to a dozen different individual fungi, and any individual fungus could be connected up to other individual trees. So what does happen is that nutrients from one tree will diffuse to another tree through the fungal network, which acts as a kind of passive feeding process. It's about 5% of all the food a tree produces ends up in its neighbors. And there's also a kind of communication that goes on. If a tree is stressed, it will release stress chemicals into itself and throughout its tissues. They will diffuse through the fungus into nearby trees as a kind of chemical messenger. So it uses the fungus as a kind of internet to warn passively other neighboring plants and trees that there is something wrong. It's not like sending an email, it's more like eavesdropping on the screams of your neighbor. But that's the closest it gets. And that sort of communication and that sharing of nutrients presumably happens between the fungi as well, within a species, not within different species, because different species will fight and try and kill each other. But that's as close. You could think of that on a landscape scale as a kind of huge neural network of communication and exchange of information and nutrients. But that's getting a bit on the fringes of what we understand as intelligence and sentience. Yeah. It'd be great if it was the case, but
one of my most favorite things about fungi and lichens, I think, as well, is that they challenge our preconceptions and even our definitions. So definitely something to think about.
Yeah.
Thinking about.
Very weird.
Yeah.
Brilliant.
Are mycopesticides being trialled in Ireland? That's quite a direct question about Ireland. So I don't know the answer, and I don't know if you know. Maybe in the UK?
I don't know about Ireland, but I do know that mycopesticides are used. There's a lot of research, particularly in the tropics, of using these entomopathogenic, these, not the zombie fungi that I was telling you about, the ones that do things to ants, but similarly, fungi that similarly invade and take over insects, things like small soft-bodied flies and green fly, excuse me. So they are used to control some insect pests. And there is definitely research going on with that, mainly because I know that when we're in Colombia, we're in a university lab, they're doing some work, and they sort of research posters up of looking at the effectiveness of different fungi on different crop pests. So yes, there's research happening. It's probably being used, but in Ireland, I don't know. Yeah. Possibly because we have different species of. I think the fungi that do that probably are, maybe there will be ones that live in Ireland that do that. Maybe maybe there's a good reason why there's not a lot happening of that. But off the top of my head, I don't know it. Sorry.
Yeah, no, we're going to look into that now, I think. Yeah.
Yeah, there's another thing to look at. Yeah, I come out of these talks with like 3 things that I'm not sure if I end up going and spending 3 hours looking at.
Out of context, you wouldn't know that, but we'll look into that. So whether mycophilic or mycophobic, this is a good question. When collecting or removing mushrooms, should we leave at least some mushrooms to do their thing as fungal fruiting bodies? And I've heard different answers to this question before. So what do you think?
Oof. Okay.
So in terms of conservation, I suppose.
For conservation, yeah. So far, the evidence suggests it's not harmful at a species level. If you think about it, you're effectively picking an apple off a tree. You're not killing the organism. So at a species level, it's not doing any harm. So conservation-wise, it's probably all right. But over long periods of time, if people are going out and harvesting everything they see, over long periods of time, this may impact the fungus's ability to spread spores and distribute itself. And given that there's also an ongoing reduction in suitable landscape and habitat for the plants and the fungi, it probably does have an impact. So I would say, given the choice, don't take it all, partly because you may have a small influence, albeit small, but also it's nice to leave them for other people to look at.
It is, yeah, definitely.
Yeah, it's like if you don't pick all the flowers, pick one and move on and get one from another. So that leave them for more, even if those people aren't going to eat them, leave them there to look at because they're awesome. And you actually, that's the point. Usually there's a whole suite of invertebrate life associated with fungi.
Yes, other ones as well.
So, and it's important for them. I think in some cases, some of these big bracket fungi, there's a thing called a giant polypore. There are potentially hundreds of different invertebrate species that make use of it for food, and there's a place to lay eggs and grow larvae. So you may not be harming the fungus, but you may end up having an impact on invertebrate life as well.
Yeah,
so from that conservation point of view, yeah, leave them be, or not. Don't take them all.
There's a good few more questions. I don't want to keep you too long, so we'll sort of do our.
That's all right.
A lot of people are already saying, looking forward to part 2 of this talk. Hoping that we do something maybe down the line, another talk. I'll talk to you about that later.
Okay.
Yeah, so we'll fire through the next few. Are there any groups this side of the world? Oh yeah, this refers to Paul Stamets' work, I think, looking into the crossover of fungi and bees and how fungi can be used to help the bees.
The bees. Oh God. There probably is. I don't know them off the top of my head.
Yeah, we'll look into that as well.
That's a good one. There's a guy who works upstairs who works on bees and pollinators and things. So he probably knows a bit about some sort of fungal involvement. I think he does plant chemistry and how that affects bees. So there probably is, and I've seen something about Paul Stamets. I think using as a mite, an anti-pest thing for something that does. I think is it varroa mite or something like that.
Yeah.
There's something in there, I'm sure. I remember reading something about it, but off the top of my head,
yeah.
The answer is probably yes, but I just don't know the answer.
What do you think of private companies who want to patent mushrooms for their business interests? I wonder, is that happening as well? Probably. Possibly.
I don't know if it's happened.
No.
Off the top of my head, I don't know. There probably are companies that have patented things. I'd imagine things like they've patented a strain of fungi. So things like corn, for instance, that uses a particular thing called Fusarium. I remember the species name now. That strain is probably patented because it's a huge thing.
I guess things that have been altered, like the citric acid.
Yeah.
Not that one, but things like that where they've
yeah. I mean, I didn't talk about industrial enzymes that we use for things. I think it's about 170 enzymes. Those probably have patents on them. Okay. On one hand, I can say I can understand why, because this sort of work takes a lot of investment and time. So I can understand that. But morally, patenting a living organism, not so fond of. But I don't know to the extent. I don't know enough about whether it's happening, I'm afraid, to be able to comment. I can see both sides of the argument, but I'm also slightly morally, particularly if it's a profit-driven motivation.
Yeah.
If it's something for the greater good of humanity, like the fungi that we use to make vaccines for us, or the fungus that makes insulin industry, that I like the idea that sort of stuff is freely available for humanity. The betterment of humanity and altruistic purposes, best thing forward. Making billionaire multinational companies billions, not so fond.
Yeah. Really interested in your last point about styrofoam. Can this be carved? I'm an artist and would love to try this for making prints. That sounds fantastic.
Potentially, yes. Off the top of my head, they tend to use straw and sort of wood shavings as the substrate to grow the fungus on. I don't know how well it can carve because it's compressed wood. It may be a bit rough and ready. What you could do is, if you know what you want to make at the shape you want, you basically get a mold of that and you grow the fungus inside it with straw, and you make your object or sculpture or something like that. So you wouldn't need to necessarily carve it. You could make it exactly the shape you want, and people do. The bowl I showed, for instance, people make lampshades. You can grow your own lampshades, things like that, using any kind of former, mold, what have you. I don't know if you could carve it afterwards. I'd have to ask someone and check.
Yeah. Sounds like a lot of fun, though, to try these things.
Yeah, you
A
can
very
think
good way of getting
that's the thing.
people
You
interested.
can do it at home. It's,
Yeah.
I guess you can buy the spawn, if you like, easily off the internet from a few places,
Great.
and then go to town and grow whatever you want. And if it doesn't work, you get to eat the mushrooms.
Yeah, exactly. Here's a gardening question. Are there any fungi that will speed up or help the composting process? So I'm guessing yes, and they're there already. I don't know.
Yes, they are there already. If you're
Yeah.
cutting down bits of, generally, if there'll be fungus in the compost heap, so you don't need to worry about adding new ones. They'll do their thing. Any plant that you cut down or chop up, like I mentioned, those endophytes, though, that plant material will be stuffed with fungal tissue anyway. And the moment it's died, that fungus will know something's up, and it will start the process of breaking down the plant material. So it's already there. You don't have to help it. Just give it good conditions for composting, and it will do the work for you.
Let nature do its thing. It's the best way.
Exactly, that's it. Yeah.
Please speak more about the Kew collection. Is this a viable spore collection or just dried, non-viable samples? So
okay. If there are spores associated with it, they are dead. I have to be careful here. For legal reasons and because of our license and DEFRA and to do with quarantine, because we're moving material across borders for research and stuff, we assume that everything here is dead and non-viable. Some of them may be viable. We don't know, but we assume they're all dead. We don't have, and we have to be careful of that, because if they were all viable and alive, it makes it really problematic to move live fungal material internationally for research. So I mean, some of the stuff's here like 100 years old. It'd be interesting to test it out, but of course the results are problematic, because if we find it's all viable, we're in trouble. So I think, I don't think we have anything along the lines here of a live spore bank. There's another institution called CABI, C-A-B-I, the acronym for which I can never remember. They have a live culture collection, which means that which they can give people and send out for research. So they have a live culture collection, but everything here we say is dead.
Great. Okay. Here's a direct reference. Which cave was the Amanita art found in? So the one on your slide, I guess.
The one on the one on the slide is the one on the slide of the mushroom man with all the mushrooms on his hands was Tassili, which I think is spelled Tassili. I think it's the same cave system as a whole range of fungus pictures. The ones I mentioned of the human bodies with Amanita muscaria heads, off the top of my head, I can't remember which cave it's in.
Where's it again? Which country is it in now?
I think it was Algeria.
Oh yeah.
I think it was Algeria. If you do mushroom head cave art on Google Image, you'll come up with the pictures. The human figures are painted in black with yellows and reds for the Amanita muscaria head. The Tassili ones from Algeria are. There's also similar ones in Spain, which has little fields of mushrooms as well. I can't remember the name of the cave. Sorry, it's Tassili is the weird mushroom man.
Great. And here's another gardening one or another plant-related one. Can you say something about ash tree dieback? So that's referring to pathogens now. They came up less than I expected, actually.
Yes. So ash dieback is a real big problem. What's odd is that the fungus that causes it is a thing called Hymenoscyphus fraxineus. We actually have that fungus in this country already, but it's not pathogenic. It's weird that this strain, if you like, that was imported with young trees has switched and is now pathogenic. Some ash trees seem to be immune. Some have certain degree of resistance, but there's a good chance that ash trees, certainly on mainland Britain, and maybe, I don't know if it's in Ireland, are stuffed. And we are probably going to lose a lot of ash trees. including ones that aren't infected but are killed and taken down as a kind of fire break. So I think there's very little that we can do, because fungal spores are a nightmare to stop. And by the time you know it's got it, it's too late. So I think the main thing is wait until is look at where ash trees have survived, and maybe begin a process of cultivating seedlings from those as a replacement.
Yeah.
But it's a lovely little fungus. It's really cute.
Yeah.
But it's killing everything. It's the same. All the cute ones are monstrously horrible in some way.
So this is referring to the Fungarium, I guess. When can we come and see the collection? Is it open? Do we need to book? So tricky in times of COVID.
Yeah, times of COVID, no, I'm afraid we don't. So we are, generally speaking, we're not open to the public, because we're in a basement building of a laboratory, and so for security we can't have random people wandering around, because there's labs upstairs, and it's a working environment. There's nobody around today, but I'm always here. There's somebody else here. We have researchers in and visitors. We do tours a few times a year. So we have a science festival every summer where we do tours. But I'm afraid, generally speaking, it's not accessible to the public. I'm trying to think of a way that if there's any way that there's no. Maybe in the future, maybe once the COVID thing is over, it would be quite nice to do like a monthly tour. But we also limited how many people we can have at a time, because I think we can only have about 15, 16 people in here at a time. It's a big room, but for safety purposes, I mean, any bigger groups than that, there's nowhere to stick people as well to see things.
Yeah.
So I don't know.
I was really lucky to be there for a tour, and there's about 15 of us. Glyn just said a streamed tour, perhaps. So a bit like what we're doing now, but you're walking around pulling open drawers. I don't know.
That would be a good thing. I mean, maybe we should do that one day. So we could do like a virtual tour. I should speak to the media people, and we could do like a walk around, pull things out, and like create a couple of shortish videos, a few minutes each, just wandering around, pulling things out.
That would be amazing. And I must say, Kew have like very, very good online media. So I mean, there are a lot of articles about the Fungarium collection.
Yeah.
Keep that way.
If you go to Royal Botanic Gardens Kew YouTube channel, I think there's a few fungi videos.
Brilliant.
Which talk about I think there's maybe 3 or 4 fungi videos. There's one of me rooting around in bushes with people, looking for stuff. There's some then with other colleagues talking about the Fungarium and fungi in general. Once I can hang out with the people I work with properly, maybe we'll do some little videos around the place and we'll do it for autumn, because it'll be fungi season.
That'd be great, of course. Yeah. Here's a very technical question. Could you give me an easy method to isolate spores? I find it difficult, or I found it difficult.
Oh my God. If you want to get the spores from a particular individual fungus, the easiest way is if you've got something like agar or a slime, is you take that fungus and you do a spore print, and you exclude the chance of any other spores getting to it. So use sterile technique, sterile environment. You could take your mushroom, rest it over to sterile pins or something that held over an agar plate, and cover it so nothing else can get in. Leave it, and then you'll get a culture predominantly of the spores that you want. Go to the source, get chunks of gill from a fungus. I think if you're trying to get them from the environment, no chance, because there's just billions of spores out all the time.
Very good. This is a comment, really. It sounds as if all fungi are good. How about, this is from a human perspective, how about poisonous fungi and ergot? My first thought there with ergot is that, as far as I know, derivatives of that are still used for women in labour.
Yes, ergotamine. It's used for migraines and also for women in labour. I think it also helps. I think it's postpartum bleeding, so that it's a vasoconstrictor, which means, so in that case it helps to stop bleeding and what have you. Poisonous mushrooms, there's so much to say. None of them are trying to kill us. It's an accident. There's a lot of unusual toxins that fungi produce as secondary metabolites. It's not a deliberate act. It's kind of just they're doing their thing. Some of them are really horribly toxic. Like the most horrible one is there's a fungus that's only found in Japan. I think they find it in Australia now, a couple of them. It's beautiful red coral-like fungus, and it's nasty. If you ate it, your hair falls out, your skin peels off, your blood clots, your organs fail, and you die. It's nasty. And there's things like death caps, horrible kidney and liver failure. There's potential for using these toxins as drugs.
Yeah.
We understand how they work. So the toxin from death caps, for instance, thing called ammonitoxin, it kills cancer cells. It's really good at killing cancer cells, and there's a lot of research into using it, targeted use on cancer cells. And they've just figured out how to make the toxin in a laboratory setting rather than harvesting the mushrooms. There's potential that we could use it in the right dose. The dose makes the poison. Ergot. That's a interesting one. Lots of use, potentially historical use as a hallucinogen, but there's also potential it was involved in witch crazes in the medieval period, because the symptoms of ergot poisoning are similar to what people described as being bewitched, like insects under the skin, on fire, hallucinating, all that.
Yeah, so much so much folklore and culture there.
Oh yeah, tons.
Whole other talk again.
Yeah.
So I thought we might have a quick look at the poll at the end and see what we got on there. So you can open it as well if you like, Lee. The first question was, fungi can only live on land, true or false? And the answer is
false.
Yes. Do you want to say a little bit about the aquatic fungi?
Well, like all other life on Earth, fungi originated in the oceans. There are definitely fungi in the oceans. It's another one of those things that's underexplored. There's actually, I think there's a single fungus that's known as that's a subaquatic mushroom. So I think it's in freshwater streams. It produces little mushrooms in streams and rivers. It's really, really cute. It was only discovered a few years ago.
Where does it live? Is it in the UK?
Oh,
no?
Off the top of my head, I can't remember now. But there's one species I know of.
Yeah.
But the rest, the fungi that you find in the oceans and the sediments won't be the same things that we're familiar with on land, because it'll be, the mushrooms that we know evolved on land to adapt and live in terrestrial environments. Yes. The stuff in the oceans will be fine, microscopic filamentous stuff in sediment. But they can live everywhere.
Just to say, I made an unintended pun with that question in the poll. So I don't know if you've heard, I know our Irish audience will have heard, there's a very famous dolphin off the coast of Kerry called Fungi.
Yes, it's the one that is it Dingle Bay or Dingle?
Yes,
is it?
You're absolutely right, Dingle.
Yep, I remember Fungi.
Yeah, so poor Fungi, he was there for many decades, and he attracted a lot of people to come and see him because he was always there, but he disappeared last year. We're not sure where he is. We're still thinking he might be out there. But anyway, unintended pun there regarding Fungi the dolphin and fungi aquatic species.
That's a good one. I'm impressed.
Okay, so you covered this in your talk. How are fungi different to plants? And the answer is
all of the above.
All of the above, yeah.
Yes,
they don't photosynthesize, and they have cell walls made of chitin.
Rather than cellulose.
Again, lichens would be a whole other talk.
As we're strictly speaking, in that case, it's a photosynthetic algae or bacteria rather than the fungus that's photosynthesizing. They're just a little commune of cooperating organisms.
Yeah. Oh, someone said fungi was potentially spotted recently. That's true.
Maybe when the tourists all cleared off because of COVID, he was like, well, I'm going to take the chance to go on holiday, and went off somewhere, and he's coming back.
Yeah,
exactly.
I hope. He's taking a break while everything's restricted.
Yes.
How many dried specimens are in the Kew Gardens Fungarium? Now, this is a very rough number. So not accurate exactly, but it was indeed.
Over 1.1 million, we think.
Yeah, which is amazing. Yeah. Actually, how many species do you happen to know? Sorry. Fungarium would it be a lot more, but not a lot more? I don't know.
How many we have? I think it's about 60 or 70,000 species.
Wow.
the hard part is that only half of the collection is databased.
Yeah.
So we know from those ones obviously what's in there. The other half will get done over the next couple of years, hopefully. If any of our people watching happen to be multi-millionaires or billionaires with money to throw around and would like to donate a few million to us, please, so we can get the other half mass digitized, that would be lovely.
Yeah, and looking to the future of the Fungarium where you work, there's plans potentially, hopefully, to expand so you can have a bigger collection over the years.
Yeah, we're kind of full. There's bits of the collection we're now, it's in these boxes behind me. And we've got 13,000 boxes like this. Some of the boxes are stuffed, and because it's organized in a taxonomic order, it's kind of a three-dimensional family tree. There are bits where it's really full, and so if we want to put something else in it becomes really difficult. So hopefully there's talk and plans going on for a new science building for all the collections here at Kew and to upgrade all the labs that are upstairs, and they'll give us a bigger fungarium, and one that's not in a basement, because we're in the basement down here and there's no natural daylight. So a nice, bigger, more luxurious fungarium, please, with daylight and windows.
Like a lot of the fungi, you don't thrive in dark, damp places.
No, and the best thing about that will be if they give us a new building, we can make it more accessible to the public. Even if they can't come into the whole thing, we'll have exhibition space around, so we can at least we've got like a display cabinet just over here with some really nice stuff in, things we could show off and do talks and get groups in on a regular basis. That would be nice.
That relates a bit back to our site in Dublin, our Botanic Gardens here. We have a herbarium, so we have the dried plant collections, and there are indeed some, not so many, but there are some fungal collections as well, especially lichens. Anyway, it's stalled a bit because of COVID, but we did, just before COVID, open a little exhibition area just outside. So yeah, the plan is to, and it's the same in Kew, to bring out these collections a bit more to the public and to explore a bit more under various headings as well. I think, like you mentioned, the decolonization, that's a whole other subject, but it's very interesting.
Yeah, there's all the plants on display in the gardens. But most people assume it's just the gardens and the plants, but they don't know that there's like a laboratory here in this corner. There's a herbarium.
Yes.
And that about a third of all the people who work at Kew, there's like 300 odd scientists here.
Wow.
Working on plants and fungi and bees. So somewhere putting that out there in the gardens would be amazing. I think it will happen because there's a lot of desire within the organization and in the public, I think, to see more of this stuff. Like the science festival we have is like brilliant. You just stick all the scientists in tents for a long weekend and you get to talk about anything and everything, and we have a great time.
Sounds really good, and I think hopefully all of our audience will keep an eye on what's going on in Kew Gardens as well as in Glasnevin, because you have amazing resources there. Like, it's a big operation. There's so much going on. Whether you're a scientist or just a generally interested, there's all levels.
Yep. There's something for everyone, if you like, within fungi as well. It's like
there's really great comments there. People enjoyed your talk very much, and there's a lot of talk about part 2 in the autumn. A lot of people are looking for more. So I really hope, hopefully with us, but even, people might like to follow you if you do other talks, not for other institutions. So yeah, I guess, I hope that we can all kind of keep up this interest and talk about it more. And just to say that this talk has been recorded, so we're going to upload it onto YouTube. Our comments there that you see there won't be on YouTube, but people who have registered today can actually just come back to this link and look at them again if they want. So, because there were a lot of books and things mentioned, I know, and they might like to look at those again. And for your own interest, Lee, I think it might be nice for you to go through and see all your friends and all the people you know as well. And see
I'll go through and read the comments. I kind of had one eye on it and I saw lots of links, so I'll go and have a look at those.
Yeah, it's great. Fantastic. So I'll wrap it up there. You've been amazing and we really appreciate it. And we'll talk to you again sometime.
Let's definitely do it again.
I'd love that. Yeah.
I'll do toxic fungi or something. I don't know. There's loads of things to talk about.
It's all about your enthusiasm and what's in your mind at that moment.
We'll do something. We'll see. Okay, awesome. Let's do it.
Great.
Thank you very much indeed. Thanks for asking me as well. It's been great fun.
I was delighted. I had heard you speaking, and one of our botanists, Nolene Smith, had worked with you in Kew for a short while.
Yeah, I know Nolene.
She encouraged me to reach out, so thanks to Nolene for that, for connecting people like she does. And just to wrap up, this is the final talk in our spring lecture series, and the Botanic Gardens at Glasnevin are going to plan more of these in the autumn, I think. We're going to talk about that later. So yeah, well, hopefully we'll have you back. We'll see.
Yep, let's do it.
Okay.
Thank you very much. Cheers then. Bye bye.